Hey guys, I just want to do a quick video, like re-summarizing difference and differences, in particular going back through this set of slides that we covered in week 4, I believe. So if you need to, you can go back and track down the slides on Bro and Learn. They're the ones for week 4. But what I wanted to do was to sort of remotivate this part of introducing difference and differences, because I've basically just been getting questions that I think are especially kind of focused on this bit here. So for my week 4 discussion, I pulled this bit right from the slides, where what we have with the full equation is the difference and differences equation. This is the thing that we're estimating every time we run a difference and differences, right? Whether we are looking at the effect of closures of local news stations on various outcomes, or if we're looking at the effect of becoming a homeowner on voter turnout or other measures of political participation. When we are doing a difference and differences, we are almost always estimating some version of this. And so what is this, right? What I first want to do is to sort of go through what do each of the coefficients tell us? What do each of the Greek letters tell us? I'm gonna just sort of lay it out very explicitly, and then I'm gonna take a little bit of time to explain how we get there. Okay, so first things first is just sort of going left to right. What does each coefficient tell us? In this case, what alpha tells us is the average turnout rate, or really it's the average of the outcome variable, right? Which in this case is turnout rate for always renters before 2008, where in this case, always renters are our control group. They're not treated. They don't receive treatment. And before 2008 is the pre-treatment period, right? So again, always renters are the control group. Before 2008 is the pre-treatment period. Conversely, if we were looking at home buyers, that would be the treated group. And if we were looking after 2008, that would be the post-treatment period, right? If you remember this kind of pre-post distinction. Okay, so alpha again is the average turnout rate, or the average value of the outcome variable for the control group in the pre-treatment period. What then is beta? Okay, beta is the average difference between always renters and home buyers, which is to say the average difference between the control group and the treated group in this case before 2008, which is to say in the pre-treatment period. So beta, right, also known as the coefficient on our flag for the group type, right, on our flag on the variable that captures, are you in group type 1 or group type 2? That is to say, are you in the group that received treatment, or are you in the group that does not receive treatment? The coefficient on that variable is the average difference between always renters and home buyers, is the average difference between the control group and the treated group in the pre-treatment period. Okay, moving on to gamma, which is our next Greek letter, just sort of moving from left to right. Gamma is the average increase in turnout, right? It's the average, it's going to be the average difference between the pre and the post period, okay, before and after treatment, for the control group. Okay, so in this case, always renters are our control group, but extending and kind of abstracting to the general case, gamma is going to be the average difference in the outcome variable for the control group between the two periods, between the pre and the post period. So if you want to think about another example where we look at cities switching from elected to appointed tax assessors and collectors, basically the cities that don't switch, right? What is their average increase in the frequency with which they assess homes, right, in the district between the two periods that are constructed by the year in which some cities switch from electing to appointing tax assessors and collectors. Okay, And finally, the difference in delta is the difference in differences. It's the actual estimate of the effect. Okay, and so if we think about beta and gamma, right, as capturing two differences, right, beta captures the difference between the control and the treated group in the pre-treatment period, and gamma captures the difference in the outcome for the control group over time, which is to say, kind of this secular difference or this change in the outcome that just happens on its own over time. Then delta is the difference between those two differences. Okay, how do we actually get there? Again, just reminding ourselves of what the actual variables are, right? Not the Greek letters, not the coefficients, but what are the actual variables that are being captured in this equation. V is our outcome variable. It's on the left-hand side of the equal sign, right? In this case, thinking about the Hall and Yoder context, V is going to be just a binary, right? A 1 or a 0, indicating whether the person voted or not. H is going to be an indicator for group type, right? And this is group type extending sort of, extending broadly. So if you want to think about juvenile versus adult that you guys saw on I think the fourth problem set, that would be another of this type of variable, right? Where it indicates, are you in the group that receives treatment or not? You can think about, again, the cities and towns that switch from elected or appointed assessors. Cities and towns that switch from elected to appointed assessors. Are you in the kind of city that switches, or are you not? Right? H would be that same type of variable. P, conversely, is an indicator for whether you're in the before or the after period, right? And so in Hall and Yoder, right, they looked at whether home ownership changed. They looked at whether a particular year, right, had an impact in terms of assigning people to home buying treatment or not. But other cases that we looked at different years, right? So again, Hall and Yoder look at 2008, right, for reasons specific to their context. The OUSS paper that we look at, I think, again, for problem set 4, looks at 1996 and looks at the policy change related in that year to juvenile justice. Martin and McCrane, for example, that we looked at for the most recent section of the course, where we were looking at Sinclair acquisition, right? They were looking at I believe it was either 2018 or 2019, right? They were looking at this year in which Sinclair acquired a bunch of broadcast stations, right? And so P, right, this before or after variable, this binary before or after variable, is just going to represent, are you in the period before this change that I'm interested in studying occurs, or are you in the period after this change has already occurred? Okay, so that's H and P. Finally, the thing that's not really flagged here, but which you can see is down here we have an interaction term, which is to say that we're multiplying H times P. Okay, we're multiplying the variable that gives us the binary indicator for whether you're in the group that eventually at some point receives treatment or not. Are we in the period in which in which members in that group receive treatment or not, right? We're going to multiply those two binary variables together. We're going to multiply those two variables that can be either a 1 or a 0. Okay, and again, this is always going to be the sort of canonical diff-in-diff setup, is just this, binary variable 1, binary variable 2, and then the interaction or the product between those two things. That's always going to be the setup. Okay, and so I think just one useful thing to remember is that is sort of how do we know that, right, all these things, this beta is the average difference between control and treatment in the pre-treatment period, right? Gamma is the average difference for the control group before and after, right? Pre and post, rather, right? Before and after the period in which treatment occurs. How do we know all that's true? All we have to do is to think about what turns those Greek letter coefficients on and off. Okay, so what I mean by on and off is if I plug in a 1 for H, right? So if I say that this person is a homeowner, right? Or if I plug in a 1 for P, right? Which is to say we are in the treated period. We are in this sort of post 2008 period, right? if I plug in a 1 for either of those variables, it's going to turn on or keep in the equation both beta and gamma, such that our estimate of v of turnout is going to be informed by those coefficients. Right now, again, remember that because we already know what the turnout is, that's going to push the unknown part of things to the right-hand side rather than the left-hand side. So instead of in a regular regression where we try to predict the left-hand side, we're instead going to be trying to come up with estimates for variables or unknowns on the right-hand side. But all of that nonetheless, right? We can think about, okay, what happens when we sort of turn on or off different variables, right? H or P, or the interaction between H and P. And so again, H, setting a value of 1 for H is going to turn beta on. Setting a value of P of 1 for P rather is going to turn gamma on. And then the only case in which delta is turned on, I think this is kind of the key thing to note, is the only case in which delta is turned on is when both H and P are 1. So when both H is 1 and P is 1, we the product of those two things is 1, right? Because if either of them or if both of them are 0, then the product between those two things is 0. But if both H and P are 1, then delta is kept in the equation, and so it's part of this estimation that we do. It remains sort of part of the regression equation. Okay, and so that's sort of what's being discussed here. Again, you have access to these slides, so you guys can take a look at if you want. But what I want to sort of lastly do is to go back through and actually see, again, going back to our original sort of arguments about what is alpha, what is beta, what is gamma, so on and so forth. Actually show how those end up estimating the different quantities that we said that they estimate. And you can do that by just plugging in the kind of appropriate values for the different variables. So the non-treatment or the control group, right, which is to say always renters in the pre-treatment period, right? That means that we're going to plug in 0 for H, we're going to plug in 0 for P, we're going to multiply 0 times 0 to get H times P to give us 0 here. And so what that's going to do, what it's going to do is it's going to zero out beta, it's going to zero out gamma, it's going to zero out delta. And so ignoring epsilon, which is just an error term that we can basically ignore, we're left with alpha. And again, if we know V, if we know the average level of turnout, right, in some period, and we've zeroed and we've sort of specified how we get to this setup. If we specify how we get to the no treatment or the always renter group in the pre-treatment period in terms of the variables that we're actually using, these H's and P's, then the average turnout, then the value of V that we actually get for this subset of individuals ends up translating to this sort of this Greek letter or this coefficient, right? Similarly, we can do the same thing for the control group in the post-treatment period, right? The only difference is that now H is still 0, but P is 1, right? And so what happens is beta is still zeroed out as it was before. Gamma is instead kept in. And the product of H and P, right? The product of these two variables, again, for the control group in the after period is still going to be 0 because 0 times 1 is 0. And so what is our estimate of the average turnout rate, right? The average of the outcome variable in the post-treatment period? That's just alpha plus gamma, right? Which is to say it's what's left over here. Okay. And so what we can do now having estimates of turnout for these two groups, or rather for the same group in these two time periods, is we can take the difference, right? So first thing to note is that, okay, no treatment or always renter group, control group before 2008, I'm saying that's alpha here. Okay, that's exactly what it is here as well. The average turnout rate for always renters before 2008 is alpha. Okay, so we know we're on the right track. the next thing that I'm going to tell you is that if you take the difference between these two things, right? So the alpha plus gamma minus alpha, you are of course left with alpha, or right. Sorry, you're left with gamma. So alpha plus gamma, that quantity, minus alpha is gamma. And so the way to think about that is it's the difference for the control group between the after period and the before period. So it's the difference for the control period post minus pre. Again, that difference in these sort of Greek letter coefficient terms is gamma. And if we go back here, that's exactly what we're getting here, right? It's the average increase in this case, but really it's the difference in turnout for always renters for the control group before to after 2008, which is to say pre and post treatment. Okay. We can do the same exercise for the treated group, right? So these were both. This was us working through it for the control group. If we do it for the treated group, then what happens? We just turn on and off different variables, right? So the treated or the home buyer group before 2008 means that H is 1. Okay, P is 0, which is to say that we're looking at individuals that do at some point go on to own homes, but we're looking in the pre-treatment period. And so again, H is 1, P is 0, the product of 1 and 0 is 0. And so gamma is zeroed out, delta is zeroed out. We're still ignoring epsilon. And so what is our estimate of the turnout for the treated or the home buyer group before 2008? So again, in the pre-treatment period, it's just alpha plus beta. Okay. And so last but not least is our case in which actually everything is turned on, right? We have ones for every variable. So H is 1, P is 1, which is, or rather, why is that? It's because we're looking at the treated group after 2008. So after the treatment occurs. So again, 1 for H, 1 for P, 1 for H times P, which is to say that our estimate of turnout, our estimate of the outcome variable, is the sum of all of the Greek letters, all the coefficients, right? Alpha plus beta plus gamma plus delta. Okay. And if we take the difference between these two things now, which is to say, if we take the difference between the post and pre for the treated group, for the group that goes on to buy a home at some point during this time period, we're left with what? Alpha plus beta plus gamma plus delta minus alpha plus beta. And what's left over is gamma plus delta. Okay. So if the difference post minus pre for the treated group, for the group that goes on to buy homes, is gamma plus delta, okay, and the difference post minus pre for the group that does not go on to buy a home, right, for the always renters, is gamma, right? So here it's gamma plus delta, here it's gamma. The difference between those two differences is just delta, okay? The difference post minus pre for home buyers minus the difference post minus pre for always renters is just delta. And what is that if not our difference in differences estimator, right? Which is to say our estimate of the effect of the treatment, right, of the policy change on the outcome variable. Okay. And so sort of why, I guess first thing is sort of what did we do? What did we do is we sort of went through and constructed the four different group and sort of period possibilities that we have. So home buyers versus always renters, or sorry, homeowners versus renters and year. We have sort of four different combinations of the values of those two variables. So we sort of go through and turn variables on and off to see the coefficients that remain in the equation for estimation. But kind of more deeply, what's the point of doing that is again just to show you how we actually get to that delta is by taking the difference here and the difference here, as well as to give you the intuition behind how you set up a diff-in-diff, right? You're always going to want to have an indicator for the group, right? Is it the group that receives treatment or not? You're always going to want to have an indicator for the period. So are you before or after the treatment period? And then you're always going to want to have the interaction term that is the product, right? Multiplying those two variables together. So sort of by quasi popular demand, which is to say people asking me questions about stuff that related to, I think, this discussion section, I thought it'd be helpful to kind of record and get this back up on the web. But yeah, again, good luck getting this stuff kind of committed to memory and all set for the final. If you guys have any other questions, let me know. I'm going to post one more thing on my module, which is just some review about confidence intervals. But otherwise, looking forward to seeing you on Friday. And just let me know if you have anything that you want to cover in that discussion section. See you then.